Am I audible? Is my voice clear?
Hello.
Am I audible?
The voice is not clear. Am I audible?
Yes, madam. You are audible.
It's clear, right?
Yes. Good afternoon all. I welcome you all to the fourth day of the online workshop on hydrogeological engineering. Part of the engineering, J and College of
I
Engineering.
think your voice is breaking.
Pardon me, madam.
Hello. Yeah, I can hear you, but the thing is that the voice is not so clear.
No,
Am I audible, madam?
Yes, you.
Good afternoon,
Good afternoon, all. Welcome all to the fourth day of Hydro-Geological Engineering online workshop. I now request Mrs. Chaya Devi, Assistant Professor, to give introduction on today's speaker.
Yeah, good afternoon, Anna. It gives me an immense pleasure to welcome today's Sister Harla for the fourth day workshop. She possesses expertise in hydrology, hydrodynamic modeling, and water resource management. She has been involved in research and commercial consultancy for more than 9 years. I have, she have exposure with experience in projects in India, Bhutan, and Nepal, funded by the World Bank, AB, and Human Development. She have experience and a broad knowledge of catchment and environmental processes and have done studies in relation to water ability and sense studies. She has been involved in design of protection work, urban flood management studies, chart of ability studies, preparation of DPR, master stress. She is even in hydrodynamic modeling using Mike 11, that is Mike Hydrover and Mike Flood, groundwater movement, and quality mode in Mike SAG. In the last 4 years, she focus was the climate change effect on urban drainage, assessment of drainage issues. In this data, areas Chennai, Thoothukudi, and Gorakhpur, and river-based studies for Krishna and Narmada Basin. New this session.
Thank you for the wonderful introduction. Now, can I start, Ellie?
Yeah, you leave your screen and you can continue, channel.
I hope the screen is visible to everyone now.
Yes, Chitra.
So as Ms. Chaya has been given a nice introduction, I would like for the opportunity that was given to me. Today I will be discussing about the mechanism on flood modeling. I will be introducing a new software called Mike Flood, which is developed by Danish Hydrological Institute, which headquarters is based in Denmark. So India, they have focused more on the urban flooding, coastal flooding, and sedimentation studies, especially in reservoir, and also recently in climate change studies. So there are a few softwares which are developed by DHI. So I will give a brief gist of the software apart from the Mike Flood. Mike Flood is a suite of software which is handling, it actually enables a platform from integrating one-dimensional, two-dimensional modeling softwares. I hope you are more aware about the recent flooding that is happening in all of India, especially in urban cities. It has a combined, what we call it like a combined or accumulated effect of climate change or like a improper planning. So there are n number of reasons a flood can happen. So we'll be dealing a few today, and also I will be focusing more on the demo part, how we can efficiently use the software. So you can now see a lot of softwares that are developed by Hydro. So I will be focusing today mainly on Mike Flood, and also it enables the integration of two different software, that is My Hydro River as well as Mike 20. I will be brief what this software does. My Hydro is a suite of software which has two components basically. The one is water balance calculation, that is mostly on the water balance of a particular reservoir or a particular basin. It can be done at any catchment scale or any scale, so the water balance can be calculated. And the second part is the pure hydrodynamic part, that is the hydraulics of river or canal or any kind of application, especially on the sedimentation part or solute transport movement in terms of one-dimensional modeling. And you can see few on other software as well. Mike 11, that is like a predecessor of Mike Hydro, an old software which is still in market, which use the same hydrodynamic and sedimentation studies in the one. It is a module which handles the groundwater saturated and unsaturated as well as the overland flow. And FeedFlow receive software for advanced groundwater studies. Mike 3 is something three-dimensional studies. That's mostly when your application focus on the discretization, especially when you introduce some structures, you wanted to see the hydrodynamic parameter, gestures, all this across the vertical zoning. So you can go for Mike 3. And Mike 21 is the two-dimensional application. And West lift back and all, it is something to do with sedimentation. West is focusing more on the, WTP, like and their movement. And urban is also can be integrated with Mike Flood. I will give just an introduction today. That is mostly focusing on the urban drainage system, like stormwater drainage, and also the distribution system, water supply system, and it also can be modeled the sewer line, especially the entire sewer network from collection point to the disposal point. So Mike Flood, when I say Mike Flood, this is a combined coupling modeling software in which we interconnect. We have a different complex varieties of drainage system or water resources, though that collects by different packages software. So Hydro River basically mostly used for rivers, natural drainage system, and urban for artificial or especially on the urban areas when you have a different mechanism in the flow pattern and all, which is like a more human interventions are there. It enables on a floodplain that is connected by especially the elevation, nothing but the digital elevation platform. So those levels are connected in on a common platform that's in MindFlood. So today also I will showcase a very small demo because of the time we have. Within 1 hour, we'll cover up a simple riverline flooding. So these are the few examples that we are recently facing a lot of issues in terms of flooding. We have, especially in the urban areas, we have more flooding, not just because of the intense rainfall. There could be a lot of other reasons as well in terms of sudden change in the land flows, in terms of improper planning in the drainages. So there could be numerous reasons that can cause a flood. The other type of flood is something we are dealing or we try to model in river flooding, nothing but fluvial flooding. That is majorly when the river is overflowing. The flow is beyond the capacity of the river system. It just overflow over the bank and then it causes flood. It's just spread the area on the floodplain and then it's causing flood. The recent changes in the climate change, storm surge is also one of the important parameter. Especially we have a lot of coastal cities. We have a combined effect of storm surge and as well as fluvial flooding. So these are the two examples where the storm surge caused the flooding, especially on the coastline. So the most important part is why we need to do the flood modeling, why we need to use the software, this kind of advanced tools. Basically, we have like two kind of steps. One is the problem definition. One, we are trying to find what is our problem, whether we have a proper flooding issue that cause a lot of financial damages as well as people lives, livelihood that is caused by a lot of risk things. And then we are looking for a solution. So until and unless we clearly define what is our problem and what is the cause for our problem, we cannot find the solution. So if we are finding a solution, whether the solution is efficient one, if it is proper for the location, if it is proper for the land use over there, if it is proper for the dynamics of the area over there, or if it is aligned with the natural catchment physiographic properties, all these can be tested based only the successfulness or the efficiency of the mitigation that we suggest. So, especially when we say flooding, we always look for a solution rather than avoiding a flood, because flood will obviously will occur. But to dampen the effect, to reduce the effect, we want mitigation solution, because we can only reduce the effect of the flood. So these kind of two activities we have to club and we have to do only with the advanced modeling software. With a lot of empirical equation will not help, because this is highly dynamic in nature, especially flood. Flood has different parameters that can be assessed. One is how much area is getting flooded, or what could be the depth of flooding. All these aspects can be clearly defined or clearly assessed using this kind of modeling softwares. So we have three sets of flooding that we just saw. In case of urban flooding, what could be the crucial parameter? How we have to define the urban? When we go to the riverline flooding, maybe it will be too easy to identify whether the bank line is low or there could be a breach that causes the flood. So, like the courses, finding a course is very easy, but when it comes to urban area, it has a very combined, there are n number of factors which cause, and the combined effect cause more damages due to the flood. So we have, as I already mentioned, we have a set of drainage system. We have canal, uh, we have closed SWT, stormwater drainage network. We have water supply system. We have sewerage network. So all this network behave totally different from a river. So it has a component. It has structural component as well. The behavior is totally different from river. When river is overflowing over the bank, when the pipes are overflowing through an inlet or manhole, it's totally different. The mechanism we have to model, we have to put in a model is by defining various. So when it comes to urban, we use Mike urban. When it comes to river, we use Mike hydro river. So all this combined effect, or you just want to look at what is the flooding effect directly from, if you have very high intensity rain, you don't need to go for a detailed modeling. You just have to focus on how much is the area flooded. You just want to focus on that. Then you go for a very simple model. So according to your problem identified, according to your objective identified, you can define in a different, you can define in different models. Either it can be a combined one or it can be a simple model. So basically our definition or defining the problem is very important. So how we do that? First, we identify the problem here. So this is the flooding. Now we have to replicate in our model. So we have found out, okay, this is the issue. So we have certain areas. Here we have very high flood. Here we have very little flood. So in terms of flood depth, we will identify, and also the total area is getting affected, and further damages will calculated. And then once it is analyzed, we'll go for a kind of solution testing. So we have identified certain mitigation measures, and we would like to test it, whether it is effective or not. That kind of testing can also be done. So there will be a pre scenario and there will be a post scenario. So from the figure second and third, you can see like there was a lot of flooding, the green color. Then it got reduced by defining certain mitigation. So those kind of activities we can do using our modeling techniques. So the whole Mike flood concept here is, we call it in a simple way, three-way flooding. So we have urban area drainage system, and we have a river drainage system. So we, certain areas will have a combined one as well. We have a river flowing through the city, and all the stormwater drains are draining different outlets of river. Then it will have a interconnection. So the connection will be made through an outfall. We call it outfall, the disposal point. And then when the system overflow, that means the capacity, the flow that is being carried out beyond the capacity of the system, drainage system or river, it will start to overflow over the bank or mats or inlet structures on the area. So the area topography, the elevation, the land use actually plays an important role. So if you have very low-lying area, we would say like it is more vulnerable. So the vulnerability totally depends upon the area also. So you have to club these drainages to your floodplain in terms of elevation. So the three types of connections are being made. So if your modeling is very simple, you have only a river life flooding, you don't need to connect with urban, you just have a two-way flooding. So likewise, based on your objective or definition, problem definition, you can go for different suite of softwares. So this is the concept, one-dimensional model, like when you have a river, so especially these are called rivers. So this river, when it overflows to the floodplain, that is through the bank. So we have to clearly define the banks, all these parameter, geology, geometry parameter. We have to uh, put it in our model by giving it different inputs. So the elevation or the topography of the floodplain will define by a grid or a mesh. So that basically depends upon which kind of tool you are going to use. So which is called coupling. So your drainage system is connected to your floodplain is called coupling. So different coupling can also be done. So basically it has a lot of features. You can, if you have a very coarser problem, then you need not to go for a mesh or very finer definition in terms of floodplain. You can go for a very coarse grid, and you can just map the flood. That way is possible. And if you want very minute problem, your area is very specific, like 10 15 square kilometer, and your drainage is very complex in that area, and you have to define every 1 meter or 2 meter the connection. So in order to make more finer identification of the problem, you go for a flexible mesh. In that you can change your grid size and all. So this is this suite of software allows all this kind of flexibility in defining the problem and testing the. And before identifying the problem itself, you have to actually understand what is your objective, what kind of model you have to select, which phenomena exactly. So there are different kinds of flood modeling as well. So when you go for a identification of problem, you go for a normal flood mapping. When you have a phenomena that is forecasted, like a warning system, so there also you do the flood modeling, but a flood warning flood model. So that is something you have a forecasted data input, and then you forecast what could be the extent of flooding and what is the vulnerable area that can happen in future. So one is already an occurred event you are going to model. So that in that case you may not be more focusing on the forecast and the data input and all. But when you go for a warning system, then obviously you will be going for the input data accuracy also. And you before, well in advance, once you select your model, you have to have very detailed data validation process, and need to make sure your data whatever going to the model is correct. And also the selection of model, whether your problem is very small and you just want, pardon, excuse me, I can't hear you.
No, madam.
No, madam.
Okay, so basically the available data quantity and your problem identified, all this will lead to the selection of the model. And you can either go for a simple one-dimensional model also, which gives just an idea about could be the vulnerable areas and which location is most critical in terms of low-lying bank, or if you have very culvert, some element that causing the flood. So basically the adequacy or the capability of a particular structure can be identified, and mitigation can be suggested for lowering or removing the structure and all. In that case you can simply go for a one-dimensional modeling. You don't need to go for a detailed 2D modeling. But whenever your problem is more complex, and then you need a more detailed output, especially when you go for insurance or damage assessment and all. Flood depth is very critical, because certain flood depth normally in national disaster guidelines says, like the flood depth from 0 to 0.25 is not a major flood issue. especially in residential areas. So it also depends upon different areas where you and if you are going for industrial, the damage assessment is much more. And if you go for a very thick, like a very highly urbanized area, the livelihood affect gets affected is more. So all this critical parameter will take, and it is like multi-function, multi-objective. So based on your problem and definition, you have to select your tool. So that tool selection is very important, and also obviously your budget. How much is the budget that you have for the study, and also the data collection, all this part. And if you have very less data available, you don't have a coarser drainage pattern and all, you don't have anything available, then you should just go for a very simple model that can identify what is the cause of problem, and on larger scale, what could be the mitigation can be done. Like this. So these are the few advantages that I have listed out. There are other software also. MicFed is like commercial software, very successful software. You have other freeware called Hecras, Hecras 2Ds available nowadays. So it's all depends upon how the user finds the graphical user interface easy. So as a starter, you can start with any software available in, and also totally depend upon your objective and the budget. This is also where Mike flood is very much suitable. You need a detailed analysis of the floodplain in terms of area, flood depth, and you have a lot of, very sensitive parameter to be considered in the flooding aspects. Then you should go for a 2D. Otherwise, if very advanced structure or dam break, all those dam break is like a very huge amount of flood just happens, and we need to find out the boundary, like how much water extent flooding extent is happening. In those cases, more advanced structures are considered. You don't need to go for it too deep. It will be too difficult to stabilize it, and it will take enormous amount of time also to represent all the structure. So better you would go for a 1D. So these connections and all I will explain it later when I show the demo. So these are the simple connection when we go for a system, a group of system combines, like as I already explained, when you have urban drainage, when you have river drains, and you have a lot of structures aligned with. So you'll go for a connection. How the flow within the system is getting transferred to the flood. So we call it links. So certain there are numerous links that are available. How you transfer your water, extra water, flood water to the flood. So we can have a connection, direct connection through the bank lines. And then if you have a side structure or a overflow weir or something on the lateral branch, then you would go for a different connection, not exactly a standard connection. You would go for this is showing the nodes that are connected to the floodplain of the river bank. So the this area is our floodplain. So when you have a river passing through and it is causing the flood, then the connection would be through the standard link. You can see more. This is this you can see the water depth, that is the flood depth. So these are the output that we get. So this I just spoke about how the lateral link will perform. This is much more, I think it will be more easy to interpret. So you have a river, and when you go for a flood line, overline flooding, riverine flooding, you can actually connect through the banks, and different modification can be done to get a very fine solution. So you will be integrating a river one-dimensional flow to a 2D plane. So whatever coming out of your river is considered as flood. Whatever going through river is not our focus. So whatever is spreading over the floodplain is our focus. So basically you can block the river flow in a 2D space, and you can see or map only the flood water instead of combining and running and making the model more complex. So this is a coupling option when you have an urban drainage. So urban drainage, the vocabulary is a little different. We have SWD, stormwater drainage. We call it pipes. So pipes are connected to a floodplain through manholes, or simply the inlet structures, but we call it manhole. So through manhole only, whenever you have flood, through manhole it will overflow and spread on your floodplain. So these connection will have two types of connection here. And if you have flooding or pumping also, like sometimes very low lying area, runoff will be transferred to the higher areas. So in that case, we'll use a pump. We just pump from the lower area to the higher area. So those connection can be made. So one is our SWD outlet will be overflowing. The manhole will be overflowing. Outlet at the disposal point, especially when it goes to a river or a canal. So all these small tertiary and secondary drains will be combined and joining to a river or lake. Any could be the disposal point. So at the disposal point also it can flood. So those kind of interlinking can be made in the softwares. So a throughout dynamic coupling can be done. Whenever any water level rise is there and flooding the area, that will be exactly mapped as it is. So this is a simple replication of how the links has been made. Basically, from the river to the floodplain. So as I already explained, like two types of grid can be, floodplain can be done. Either it could be a simple grid, that is, X and Y axis will be equal size grid, or it can be a flexible mesh. Basically, depends upon how finer you have to define your problem. So this is a simple, this is actually a post-processing flooding map. Flooding map, you will get a simple flood depth, and also if you wanted to map the duration, then there will be a flood depth and flood duration. From a threshold depth you define, like you define. So this will have, if you have a 3D, especially there are more advanced technology called BIM and all. When you have vertical, like height of the building is there and ortho images are there. So there are many tools, external software you can use to post-process our results. So when you have very simple result, like a 2D mapping, that can be converted or interpolated to a 3D mapping. That is what this output actually indicates. And the same way, we can actually simulate the India flooding event. So when it is getting flooding and all, you can see where it starts to flood, and then the moment is exactly captured. And this can be converted to a video output. This can be converted to a .avi format. So all this can be done using different external softwares. So this is another levee failure. So when you have a breach in this one along the river bank, then exactly where is the location that breach has happened can be also identified. So let's start with the demo. I hope you got at least some idea regarding how we have to define, and then how we have to select the model, and then how it will be like, what is the basic output that we get once the modeling is over. So today I will be explaining Mike flood with a very simple riverline flooding. The urban areas and all is critical while running, so that's why I am using a very simple model, a very small stretch of river which has a tributary. So I will start to show how it is. The software is called Mike Flood. So once you installed, you can actually download from DHI website this software. It's very easy to download and use it. But in order to run the model, you need a license. So once you install your software, if you search for this it will shows the GUI. So once you open, you will get a GUI like this. So you go to file, then you can see a lot of other software as I given in the introduction. There are different kinds of software. So we'll be like just opening MyFlood. So here you can see there are 3 components that can be coupled here. Today we'll be dealing with only river as well as the 2D. So riverline flooding will be mapped in the 2D plane. So this is already an established model. So we actually start with not exactly from MyFlood. This I just wanted to show you how the model looks like. If you are very good in GIS and geospatial data analysis, this model GUI will be easy for you, because it's all kind of coordinate based and spatial data like feature data, raster data, all this format little different format extension, but overall the data you handle like features or raster, you can convert it into various format. So my pseudo software, it's actually 1D temporal data, it has a different set of file, and 2D, it has a different set of file. So when it handles with 2D data, raster data, it will be mostly in grid format. So we will just start with a river model. So river model is done in MyHydro-River. I don't know whether you are familiar with Mike11. This is the first software that is developed by DHI. That is simply one-dimensional river model. And then they introduce that GUI is little different from the other softwares available in the market. So recently they have changed the GUI of Mike11 and entirely named as MyHydro-River. So that will be the same way we have opened MyFlood, we can open MyHydro-River. So this is a typical river. It has a tributary. So this is the confluence point. So the minimum data requirement in order to set up a simple river model or a canal model, open canal model. When you think about that, the entire processing will be captured entirely depend on the bathymetry or the river cross section. And obviously, what is the quantum of flow, like how much flow will be through the river? That is either if you are going for a particular case study, a certain return period flow and all, you have to calculate. You have to do the flood frequency analysis, or you have to do the IDF calculation, and then you put take as data input from your calculated one. When you go for an event, particular real-time event, suppose a 2015 event in Chennai that happened. So when we are going to model the 2015 model event, you have to get the flow data. So if it is gauged, obviously we'll be able to get the flow data at certain location. But still your area of interest is this. So your boundary condition to this branches should be measured, or it should be extracted by various methods. So as you all already dealt with hydrology and rainfall runoff modeling and all. So for ungauged basin, you have to go for a rainfall runoff model and generate the boundary condition. Then you can provide here. So first, once you have the survey data, and obviously you take the note that smaller rivers and bigger rivers, when the morphology is very important, the bathymetry or survey data is important to calculate the capacity of the rivers. Why it is important? Because whatever the elevation data or digital elevation data we are using, it will not capture the actual bed level of the river. So in those cases, we have to go for bathymetric survey. And also, once the survey is done, you have to, whatever the digital elevation you are having, either the surveyed one, you have to compare with your bag level and also the floodplain levels. So that kind of validation, whenever you get the data, you have to do the kind of data validation. Then only you will start, and then you have to rectify it. If you have a data gap, then you have to fill the data gap. All this pre-processing has to be done well in advance before setting up the model. So in case if we are giving a wrong boundary condition, obviously that result will not be helpful for assessing the problem. So we need cross-section data, or we call it bathymetry data. That is in normal format. Normally we get it in a AutoCAD format, or it could be in Excel. So a typical cross-section, I would actually show you how it will look like. So this is a typical cross-section. So based on your type of bed, you will define the resistance coefficient. Here also, we have different varieties of resistance coefficient you can apply. Either you go for Manning's N, or either you go for Manning's M. So based on all your study area, you define it. And also, if you have canal system, obviously, if you have a lined canal, the resistance system will be big. So this kind of cross-section would be required to set up the river model. So this is the preliminary data requirement, and then what is the flow condition? If you're going for a particular event, that flow data or hydrograph have to be either generated. If you have already an observed data, that has to be given. And your area definition should be actually limited to your area of interest, because you don't need to model the entire river wherever your area of concentration. So you have a specific flooding point, and that you have identified from various reporting, like either it could be a satellite imageries on the flood day, or it could be various reports that have been prepared by the WRD department or CWC agencies like CWC. So all this uh, data collection has to be made, and then you assess, okay, my area of interest is only this much. And if you are going for only a culvert assessment or bridge assessment, then the area should be restricted to that. And then you have to give the boundary condition. So it's simply either you can, if you have Google Earth Pro, then you can draw your line and call a shapefile here, convert that into a shapefile and call it here. So if you have an already a shapefile of the I think you're familiar with shapefile and feature file, so I will use that word only. If you have any problem with using that, I can simply use the alignment, river alignment. I hope it's okay with that, right? Shapes. Hello. Can anyone just respond? I can use shapefile, right? The file format. Yeah. So, and converting that shapefile to a river alignment is so easy. You have different tool to do that. And if you have a DEM, then you can actually delineate the river from the DEM as well. So there are different methods that you can make the river shapes. So basically, if you have a background layer, just any image which is georeference, then you can, this is actually a background layer. Available, you have to first delineate the river line, and then you can delineate the catchment. Everything can be done using the background depth. So this is this image is not georeference. That's why it's not available on the background. So be careful when you read a image file also that it is it should be georeference. If it is not georeference, then you have to put the image coordinates here. Then it will be visible on the back. Then once your river line is digitized or delineated anyway, you have to define the cross section. So the cross section is also has to be defined. So this is like a tributary, so it will act as a different branch. So this is our main branch, and this is our tributary. So the cross section should be given. It is identical to the river name. So once we have here we have two river, that is Salmon and Trout. So the cross section should be defined as per the river name, and also it always measures from upstream to downstream, so that you can see the flow direction. So this cross section has to be given from upstream to downstream, because upstream it reads as zero or whatever the start chainage, and then downstream it will be like increasing order. So this river also in the cross section you have to define by the river name. So you can see the river name and the cross section changes like this. So this is very sensitive, case sensitive. And once you give the cross section, either surveyed or collected from any other sources, then you have to define the resistance parameter, what type of beds are there. So lined or unlined, accordingly we have to give the bannings. That will be given in the cross section itself. Or if it is the same bed, we can give is in the bed resistance value, like 30 for the entire rivers. So it can be given as a uniform as globally, or it can be typical to the cross section. And if you have a cross drainage structure, weirs, culvert, that can also be modeled. But here I do not have any structure in this model. It's very simple one. And then there is a boundary in which we have here 3 open boundaries. So if this is a tributary, this downstream of the tributary will be connected to the confluence point. So this boundary is closed. So we have 3 open boundary. So we have to give minimum 3 open boundaries in order to define what is the mechanism coming, like what is the flow coming here, what is the flow coming here, and then what is the downstream boundary that actually influence the flow coming over here. So basically, what is the discharge coming over? The water level is totally depend on what is your water level or QS relationship, anything. Downstream boundary will have an impact on the flow coming. So if you have a coastal river and there will be like downstream boundary will be tide, obviously the tide backwater will be considered 2 and 4. So the downstream boundary and upstream boundaries are open boundaries are very important. And also, it's not only the open boundary. You can give intermediate if there is a small lateral flow coming, or you have a pumping station here. So all these boundary types of boundary condition can also be modeled. So this is the standard boundary condition. We are giving flow here. Mostly we give the upstream as flow, and then down is either QH or rating curve, or you can give it as a downstream boundary water level as well. So if I go to the boundary, you can see 3 boundaries has been given for salmon, 2 discharge inflow boundary, and QH is given for the downstream for salmon. And then it has something to do with the entire, initial condition. If it is any retention, water is there or minimum flow is there, we have to give the initial condition. So if you are starting, a typical event is being modeled, then when you start, okay, I'm going to start on 29th September. So what is happening on the 28th flow boundary condition, that can be given as initial condition. For normal testing scenarios and all, you can give a minimum flow depth or or minimum flow, that just to avoid the dry bed and also initializing the model in a stable manner. You can give some kind of initial condition. So that is specified, and then you just have to store your result. So basically, the NDL modeling activity that is totally depends on your if it is a steady state, it has nothing to do with the simulation time and all, but it's very small model. So we are running for, if it is running for 3 days and all, running time will be very small. But if you have very complex river system and drainage system, then the NDA simulation time depends upon the data input, and also if you wanted to generate or simulate a month event or like 5 years or 10 years event, something like that, then the entire simulation time will be like a day or 2 weeks, something like that. So totally in those cases, your stabilizing model is very important, because the flow that is coming, especially in flood application, the flow that coming to your river system is huge, and setting up 1D and stabilizing within that capacity of the river is very crucial. In that case, you have to play with your simulation time step. So what interval you will run your model, that is one of the stabilizing criteria, and also the spacing between the cross section. If you give very close cross section, then it will have n number of like enormous amount of like calculation node. So each cross section, it will be it will be considered as a calculation node, and also intermediate cross section, it will be considered as the flow node. So that many calculation node you will have. So the entire simulation time will increase further. So all these parameters, all this consideration has to be considered, because you have to stabilize the model. At the same time, you should not overuse or underuse the model application. Basically, it should be very crucial when you go for a sedimentation application, because you basically need to see long simulations, like after 5 year or after 10 year, what could be the sediment that is being deposited in the river and all, or morphological, especially in morphological application, there are like long. But in flood application, our simulation is very less, so we can go for a very low simulation time step, and also you can go for a closer cross section. So my NDA data input is over. I am going to run it. So before that, you have to specify the simulation time and time step control. As I said, it will be running for 20 seconds. So you just check for the validation and try to simulate. So water level is something above QH locations. So I got some kind of error. So you have to rectify what could be the error and all. So here they say water level is something 8.5873 is above the water level of QH. So we have a boundary condition that controls the downstream water level. So which is actually coming very high. So either we should work on the like rewrite the boundary condition, little alteration can be done. So the 8.56 is our water level, maximum water level, corresponding a Q of 8,000 something. So, but the calculated water level is so high. So if we give some 10, 20, that could actually solve the issue. But in that case, there is a chance of misinterpreting that the boundary condition can actually impact our flow calculation. So to avoid that, we can play with the time step in order to reduce or dampen the effect, or if you're directly going for a 2D application, so your water level is high, which is not within your bank level, so it will transfer the whatever the extra water will be transferred to the floodplain. So if you couple with your floodplain, this problem will get avoided. Or you can, if you are focusing only on 1D, then you have to little play with your boundary condition as well as your time step control. So in order to dampen that effect. So that kind of higher application has to be like those steps has to be taken well in advance. So once you deal with all this model, you will be able to become expert how to handle those problems. So it will not learned overnight. It will be used and it will be understood and it will be like handy only when you get experience. So now still it is having error. So I'm not going to rectify that at this moment. I will just look into 2D, how it can be modeled. So 2D, 1D is having enormous data because it has a lot of cost drainage structure. It has the bathy. So 2D is something you are representing your floodplain. So whenever the channel overflow is happening or drain overflow is happening, that will be getting spreaded on the 2D. So the 2D vital parameter is very important parameter is something your elevation, the gradient of your floodplain. So based on that, and also what type of floodplain you have, whether it is highly, a paved kind of floodplain, or it is like a very aggregate or a vegetative, highly vegetative floodplain. So that you have to represent in terms of Manning's number, resistance coefficient. So there are typical table in different sources that says so for highly vegetation at the depth of this parameter vegetation Manning's number has to be adopted, and for a very dry area like a very fine permeable soil, it vegetation sorry the Manning's number has to be this. So that kind of category can be adopted and distributed on your floodplain, or you can go for a simple one Manning's number that actually represent the average of the floodplain. So we are representing in a two different way. We call it the bathy. We call the elevation or the topography level. We call it bathy because it is kind of a flat plain. So the water will be spread over the topography. So we call it bathymetry in mind. So it is a typical bathymetry file. You can see this is nothing but a raster file, a grid file. It has a 100-meter grid space. So each level is representing the elevation. So each level, you can see if you click that, you can see the elevation. So when you have a .py file as your DEM, you can convert that into the mic supported raster file, which is nothing but it's called DFS2 file. So it has over X and Y, how the elevation is varied. You can see the elevation. And the variation is also, it can be, read from the legend. Excuse me. So this is a typical, that's what I told earlier, that if you're very good in handling geospatial data, preparation of the input file will be easy for you. And we are going to give in certain cases, we don't need to depend on the flood, actually flood that's happening from line. In case, if you already know what is the flow at certain locations, and you are more or concentrating on the floodplain, like how much is the area extension and all, vulnerability, a general vulnerability assessment. In that case, you don't need to combine the 1D and until and unless you know exactly where your bank is, overflowing and all those kind of details you are not looking for. You are simply looking for a general floodplain map. Then you can go for a simple 2D. So in that case, you can provide, there's an option called source and sink. So you can give the like boundary condition by giving a isolated source, and then you have to apply, okay, from file. So this is the flow that is happening here. So that can be given. But if you're coupling the 1D river and the floodplain, then you need to go for a inland flooding, hydrodynamic, and then inland flooding. There are various other options also, but due to the time restriction, I will not be discussing that. So, and this is something that actually stabilizes your initial floodplain. So this is the initial surface elevation, nothing but it can be the same ground level. So your it is not at all flooded area. It is like a dry area. So your water level is exactly on the level of the ground. So initial level will be equal to the elevation. So that can be given over there. And then is called resistance. This is also a calibration parameter. I will later on I will discuss what is actually calibration parameter. So here we give the Manning's number M as constant. You need not give as a constant value. It can be a replica of your land use parameter. So you can, instead of constant, you can give a data file and then a spatial, just like the DEM raster file, you can put the spatial variation of the Manning's number. And then here we'll get a temporal and spatial variation of the result. How is the flooding happening all of your floodplain? And then out of that, we'll be looking for some aspect. What could be the entire simulation event? What at a particular location? What could be the maximum flood depth that happened at a particular location? And once it achieves the maximum flood depth, it will start receding. Then what is the total, threshold duration? Suppose we are taking dry bed from the zero water level to achieve the maximum flood depth, and then it receding to zero. So the total duration, flooding duration. Or if you are only looking for a critical flood depth, then you have a threshold flood depth. Suppose 30 centimeter, 0.3 meter. Then you can provide your threshold depth as 0.3 meter and just run it and then see what is the total duration of flood depth that is more than 0.3 and it achieves some maximum flood depth and then came back to receded to again 0.3. So the total duration. The duration is very important because when you plan for mitigation, especially low-lying area, the entire complete reduction in flood cannot be achieved. Especially while I was working in Chennai and all, the complete reduction is nowhere possible because it's all low-lying area. We call it drainage congestion. Because all your flooding area, area is the same as your river HFL level. So the water will not be disposed so fast because there is no gradient. So it will be slowly disposed. So the deduction and also the flood duration, if we can achieve. So without any mitigation, the flood duration may be 21 day or 2 days, it is getting stagnated. So when you introduce pump or any other kind of mitigation, when you increase the bank level and all, there could be a little reduction in flood depth as well as the duration can be reduced to 3 hours or 2 hours. So that damages corresponding to 3 hours will be very less compared to damages that is being caused for 24 hours. So all damages like industrial damages and the livelihood damages and the amount of production that is being stopped during that, all the financial damages will be reduced if you reduce the flooding duration. So in those applications and all, you can play with the maximum flood depth as well as the threshold flood depth. So once you set up your 2D, you have to make sure, okay, my 2D is running fine, and then just test it and then save it. Then you have to actually connect to the suite of software that is the Mike Flood. which actually shows the integration of 3 coupling, but here I am dealing only 2 coupling. So I just call the 1D river model as well as the 2D model. We just have to browse it and then call the file. That's it. Now, once you have this one, you have to actually give the coupling or the linkage. So here, the floodplain is communicating through the banks. So whenever the water level in the river, if it is above that, so it will, the flood water will be going to the floodplain. And if it is lowering, the water is getting lowered in, then it will come back. So that kind of mechanism is being, communicated through the links. So here we have 2 rivers, like one is tributary. So all the flood water exchange will happening through the bank. So we have to provide the bank linkages. So it's all lateral link. We give the right and left bank of Salmon River and right and left bank of the Trout. So if you have any, side structures and all, it will be connected to a different, you can see what all linkages can be done. So this is a typical linkages. So this link is provided. Once you provide the link, you just have, you will get a, highlighted red button here. So that means it is connected to the floodplain. So this can be automatically also called. So if you click right click, once you call both your setups, then you can directly do through the link river branch to surface model option. So your river will be there, river salmon on trout, and from this drainages to this drainages I wanted to see. And then instead of center, you have to go for both left and right. Then the linkages will be automatically created. Okay. So I'm trying to run it. So I hope it will be completed in 4 or 5 minutes. I can hear some background noise. Miss Chaya, can you unmute the participant?
Dear participants, if there is any queries, so at the end of the session, we will make sure that queries will be answered.
Last 15 minutes will be open for queries.
Yes.
Yes. So Jennifer ma'am, can you please mute yourself?
So the simple flood model is done. So we'll check results. So you will get 2 types of result. One is the result generated from your river model, and another one you will get it from your 2D model. So I will just open and show how your so this is a typical result. This is actually, this is not a direct result extension. You have to use mic view. For that you have to install mic view also for 2021 version onwards. Okay, earlier version, if you are downloading earlier version 19 and before that, the mic view will be automatically installed. But if you are installing latest version, then you have to install mic view separately. And using mic view, you can open the 1D result. So this is our the plan of the river. So if you want to see the longitudinal profile, you click this option, longitudinal profile, and this is our Salmon River. You can see the water, water level, and there are various other options as well. If you see water level and discharge, both you can see wherever the grid. Suppose you want to see the flow over here, then you can just click here. So you will see the maximum discharge that pass through that typical location. And also you want to see how much is the water level, or if you have any additional parameter to be checked, especially velocity and all. So you have to actually create the additional parameter, check the additional result parameter. Then you will get not only the result file, there is a HD add additional parameter. Then you will be able to see a lot of other results. Lateral flow from mine 21, left and right, all this can be viewed. This is typical 1D. So in 1D itself, we can see whether the banks are overflowing in a single 1D. Then if you couple, then the water level will be spread to the bank level, because the whatever the water overflowing will be taken to the 2D floodplain. So this is a typical result file that you get from 2D. So this is a raster file, DFS, we call it DFS2 file. So this at 0 time step, you cannot see anything, and slowly you can see the flooding. And it also depends upon the smoothness, also depends upon the storing interval of your result. So this result file can be directly opened, but if you want to for a customized option and all, automatic simulation and all, then there is a result viewer, 2D result viewer. That is also you can get from Mic 0 option. So under tools, so result viewer is there. So you can just simulate. So the entire simulation will be. You can see how it is going, and also you can smooth it by using contouring, and you can do. There are very like enormous number of options that you can make your very smooth results, and this can be actually saved as once you stop, you can save as a video. So I will show a typical video also, how it is being saved as a .avi format. So this will be a typical video that is being saved. So,
ಎಲ್ಲ ಪೋಸ್ಟ್ ಕಳ್ಸೋದಾ ಆನ್ಲೈನ್ ಇದು ಆನ್ಲೈನ್ ಪೋಸ್ಟ್
now you have so once you identify, okay, where is my critical area and all, the thing is that here the flood depth is very high because you didn't actually block the river portion. You actually have all the flood that is on the river as well as on the floodplain. So in order to avoid that, you wanted to see only the flooding area, not the river portion, because river portion is always at the water. So we just want to map only the outside. There is an option called blocking. So here we can see there is no blockages. we actually we are calculating the water depth here in the river portion as well, which is already calculating from 1D. So that can be avoided using a block option. So that the entire portion in between the left bank and right bank can be blocked, and the flood map can be prepared based on the blocking option. So we will actually stop the calculation by blocking the bathymetry here. That option is also available in order to make much more, finer and very beautiful flood map. We can do that. And once you have done the flood map, you probably will find the reason and you mitigate something, and you wanted to compare the pre and post kind of scenario. So in that case, you can have a comparison plot, which is using Mike 0 result, your plot option. So in this case, I already used a comparison. I have like two kind of scenario, and then I just wanted to compare at a particular like how it is getting flooded. So you can exactly compare. Here you have the hydrograph. So at what time it is actually getting spreaded, how it is being reduced, and pre and post scenario can be compared. So these kind of higher applications are available. So the assessment is very important, because more than developing the model, what you're going to do with is very finer assessment, finding the problem, how you define your, the entire river network or drainage system. And this, if you even give the proper, input parameters, input flow data, hydrograph, everything, there may be chances, because whatever the resistance parameter we are using, there will be slightly variation from the actual scenario. So in case of mitigation or any kind of suggestion, that is actually, you're trying to implement on your actual problematic area. Whatever the model you develop, it is better to calibrate. So if you have a gauged catchment and all, obviously we can calibrate in different. If you have a long measured observation like 10 years, 20 years, so we have to run the simulation like 5 or 10 years, and then the next 5 years can be used for calibration. So either you can calibrate with flow, or you can calibrate with water level measured, or you can calibrate with flood depth map created for that particular event from the satellite imageries or any array. I think, ISRO and all, they are creating now flood maps and all. So any kind of base map or a collected map can be used to calibrate your model. So that kind of calibration can be done, especially for urban areas and all. It will be difficult, because we have too much complications in the, and there is no observation data available, especially in India. So those urban drainage will not be suggested, but still, if you have any river model and all, it will be like obviously it has to be calibrated. Then only it will reflect the actual scenario. So the calibration has to be done for any kind of actual scenario. So I think I'm almost done. Now we'll open for queries. Hello.
Madam.
Yeah, we can have a discussion, like not exactly in a query. You can discuss with your point of view, because you will also be working in some kind of consultancy business and all. So you can have your thoughts, and it can be discussion as well, not exactly a query. So those who have query, they can also ask.
So participants, if you are having any queries, you can. Madam is online, so that she can clear your doubt.
or you can just put it in the chat box in the messages. I can read it from there.
So there is one query, madam,
Mhm.
for here.
So
So when we are going for a flood monitoring,
Mhm.
will the slope of the area, like the slope maps that is being available, be useful?
If you're going for flood warning and riverine flooding, I think you can take a high resolution dam. But if you're going for a urban area like Bangalore, Chennai, it's better to have a very low, very finer dam, like 3 meter, 5 meter of resolution. Otherwise, you can go for 30 meter SRTM. It's suggesting is the warning, it will be like 8% accuracy and also it will depend on how is the data accuracy you are using. Please, any other queries?
Yes, madam. One more query is here.
So
So is the software that is being developed is available at a nominal cost or free of cost, everything like that, madam?
No,
It
Hecras
has been
is
developed
available free of cost. The one I had just demo, that is a commercial software that I have to purchase from DHI. I will type the company name. It's actually, I was a previous employee of DHI. I worked almost 8 years in DHI. Now I recently started to work as a independent consultant.
one more question, madam.
before
We go for a flood monitoring, all the base maps should be prepared or it will be prepared only in advance itself, madam?
For
Like your geology map, geomorphology map.
It actually depends on geomorphology is not so important because if you are running the flood without the sediment transport, that will be easy because if you're running with a lot of other components, the simulation time will be more. Especially you have quality issue with the surface runoff, then you can go for it. If you do not, if you're not, looking into the quality issue, if you're looking only the, flooding area and flooding depth, better you look for the, river bathymetry data and much more finer depth of the floodplain, and also the observed data that is going to be generated. Basically, if you're using, in case there is no observed data available, then obviously you will be going for a rainfall runoff model and generating the runoff from the rainfall runoff. So that calibration rainfall runoff is important. In that you need various on your activities. That has an important role. So in those cases, all the maps should be verified and replica of the same parameter has to be embedded into the model.
Okay, thank you, madam. I spent by getting a few answers. Any more questions? You can post it to us, or else you can post yourself
I
in the
hope
result box.
all the teachers association, the participants are
Many of them are
institutions.
research teachers.
Okay,
Yes,
so now I actually suggested to some of the universities also here, like 9 universities in Chennai. So talking now, if you are able to, incorporate the modeling techniques and modeling software, that will be too easy for the students to understand the mechanism. Because I was actually, when I was doing the masters, we got opportunity to learn only RGS. So we were aware of the spatial data, but the application in terms of the modeling software was very limited in that time. But now people are learning more from the YouTubes, and all other platforms are helping students to understand the mechanism and understand the softwares available. So it is always good to incorporate in your curriculum as well, a typical lab section or something like that on the modeling software. Now you are aware that okay, there are modeling software available, so someone can get a quick training from different institution and include in your curriculum. That will be too useful for the students. That's what I personally believe, and I suggested to various other university in Kerala also. They have few institutions. They included mic in their curriculum. Even for BTech students, I think they have included. Yeah, one of the university. I don't remember the name, but they have included in their curriculum. So it will be really good exposure for the students as well.
There is one more query. Can you give the demo for the students also who are pursuing their undergraduate in BE or anything like that?
Yes, yes. I will have a discussion with Ms. Chaya, and then obviously, yes. I used to give training. Last week also I give one training. I used to give training on my flood, sedimentation, and groundwater modeling also. My she is the so I used to give training. Yes.
But apart from, if you have any other queries, you can ask. Madam is online. Or you can
Because this is I think this is just like an introduction to the software, so it will take some time to understand the mechanism and getting awareness on the software. And there are many other tools also available, because the entire modeling process totally depends upon your pre-processing and post-processing your result, pre-processing your data input and post-processing of your results. So that also have some kind of external softwares, tools that you can use. Especially RGS and all is one of the best tool that can be used for data input preparation.
I think there is no more queries from the participants for now.
Mm-hmm.
Any queries, dear participants? I hope Panama has given most of the answers to the queries posed by the people who are joining in this group.
Okay, I think can we have a wind up session then?
Yes, madam. Madam.
Okay, it was a nice opportunity, wonderful opportunity for me to take a handle a session on flooding aspects and familiarization of modeling tools. Because most of the institutions are now they are taking up their own consultancy work and they're taking up their own research works that can help this kind of using this kind of tools and also gaining more knowledge on the tools available, because these are some technologies that has been developed in 90s 70s. In India, we started, even the mic softwares are tested, in our Brahmaputra basins. Mike Levin and all tested in 75 or 76, I don't remember the exact year. And later onwards, we had India is a country where we have a lot of water resources, and it has that many problems also. So as a consultant, when we deal with this kind of problem, these tools and techniques are very useful. And some of even my colleagues are still using old techniques, but when we have very advanced tools like this, it will be very easy to understand. The current problem, one of the problem I am dealing in Abu Dhabi, they have a very high flooding issues that is happening because of the groundwater. So these kind of tools actually, helps a lot to assess and find out what is the problem and what is the reason for finding this kind of problem. So this actually makes our life easy, and also to make a much more finer assessment. These tools are very helpful. So I suggest you to include in your curriculum and also make aware of these kind of tools and familiarization of tools to the students community as well. And I also thank all the participants for your patience and also organizers for this wonderful opportunity. Thank you.
It was a very wonderful session, and I think there was a lot of insight on the new software that you have developed and you are working on. So, Department of Civil Engineering, Jain College of Engineering is thanking you very heartily for your acceptance of our invitation and giving a session on this flood modeling. Yes, India is one where there is of the flood aspects that every now and then we are going to face, and we make sure that it will be included in the syllabus also, curriculum also for the students for the benefit in the upcoming days, because more of the urbanization, the river groundwater is depleting, and the river water has always got impact on the cities itself. So that's why this is one of the very major issues which Bangalore and Chennai is always facing. Really, thank you, madam, for a wonderful session. Thank you very much.
Thank you. Thank you very much. Bye.
Bye, everyone. Dear participants, feedback link has been posted in the message chat box. All of you, please